Hello everybody and welcome back here for our final section. To top it all off, we talk about soil pollution. What do we see in our image? So we have modern agricultural workers who are spraying pesticides and fertilizers. Ashamed to say I don't know which one. I think they are spraying chemical fertilizers here over a field. Now, it's important for us to recognize something before we even get into this even a little bit. So, human beings need food, right? They need food. There's a lot of them who don't necessarily have enough food or are food insecure or are even outright deprived, right? So farming is good, all right? Farming is a good thing. Making food, producing food is good. What we're going to talk about are some of the side effects, right? And careless practices that can end up doing more harm than good. But we got to remember, at the foundation of it all right? Human beings have needs. They need to eat. People who grow and make that food, we're not going to demonize them, but we can recognize, right, that sometimes their incentives lead them to behaviors that cause these negative externalities, right, cause these costs for others, at which point it becomes a collective action problem and it needs a collective action solution. And if a collective active solution is put in place, everybody winds up with more of everything. It is not a zero-sum game when we go to solve these problems. If we can work them out, people can trade, and everybody winds up with more food and stuff than they would have if everything was kinked up. Okay, with that context out of the way, and important for us to remember, let's get into soil pollution. We need to talk about runoff, and we need to talk about blooms, but before we can get there, right? So our world's population is expanding. It is expanding by a lot. And not only is it expanding, but people are moving into cities. And the people in cities, do they grow their own food? No. They import it, right? From other areas. They import it from rural areas. And as these cities get bigger and our population gets bigger, there's more and more food that needs to be produced. So when we look at production of food, right, and the use of fertilizer in order to grow crops, right, we notice that it's going to be going up over time. We shouldn't be surprised by this, right? And over this kind of time scale, we're looking, from 1960, right? We will notice it especially goes up in places where we've got developing countries whose populations are rapidly expanding. Not necessarily in our developed countries. Now, as we'll see, these developed countries and developing countries run into some very similar issues, right? But the context of those issues makes them different. We have to treat them differently depending on the level of development. So, fertilizer is plant food, right? We talked about how plants need nitrogen, how they can't just get it from the atmosphere. And while sometimes in a healthier, better environment, right, they can pull as much as they need out of the soil, that doesn't always happen. Sometimes crops need to be grown, or I'm a farmer, right? I need to grow crops to make money, and we need to feed people, right? Overall, right? And so we end up using a lot of fertilizer, and maybe for one reason or another, not always using these other practices, right? So we're dumping more and more fertilizer, right? We see millions and millions of tons of fertilizer being used, more than ever before, right? In order to give the plants what they need. Nitrogen, more than anything else, but to a secondary degree, phosphorus and potassium, NPK. Something we should know is that when we're measuring fertility with our soil probes, what we're measuring is actually a sort of aggregate of these three things, nitrogen, phosphorus, and potassium. That's what makes it fertile, right? And is in fertilizers that we buy. But careless agricultural practices, or we should say short-sighted agricultural practices, can deplete the soil, right? So that more and more fertilizer is needed. Does all the fertilizer go into the plants? No, right? And the rest of it is not necessarily taken in by the environment or the organisms. But it doesn't disappear. Stuff doesn't do that. So what happens? Well, what happens is it rains, right? And as it rains, right, we pick up fertilizers, all right, and we bring them all the way out through the streams into eventually the ocean and to lots of other streams and rivers along the way. There's multiple pathways here, so fertilizer can infiltrate into the ground and move through groundwater out to sea. It can move through rivers and streams, as it commonly does, but it can also come not in a river or stream, just we can almost imagine like a sheet of water running over the ground, right? Ground runoff. This is not good. We don't want fertilizer to do this because it can lead to blooms, right? And blooms will lead to another consequence that we'll look at in a moment. These are algal blooms, right? So this is red algae. This is what it's actually made of on an individual level. This is a thing called a dinoflagellate. Very interesting little organism we see, right? So that's 30 millionths of a meter scale for this thing. It's small. It can reproduce incredibly quickly, all right? It just absolutely booms, right? So excess fertilizer is applied, right? Because we're not necessarily taking care of the land very well. Rains, runs off into the ocean, and now we get a boom in plankton population. As it booms, it sucks up, literally sucks up all the dissolved oxygen in the water, and then it dies. And because it's taken all the oxygen with it, so does everything else, right? And you have all these dead plankton, right, wash up on here. There's some striking images of these things. I mean, the entire sea turns red, terrible, kills all the ocean life, and can lead to these things called dead zones. Now, there's one in particular for those of us in the States, which is very significant. So here's Texas, right? We're on our south coast. Houston is here. If we were to follow it, right, it starts to kind of make a point, right? And Mexico's here. This is our Gulf of Mexico and our neighboring state of Louisiana, which is important, right? So it is a zone where we have really low oxygen in the water because of our dinoflagellate boom or some other sort of plankton, right, that booms. Specifically, right, we got less than 2 parts per million in this big zone, and fish need at least 5. Ideally, right, we need like 10 plus, right? So this thing cannot support fish life. At its largest, it shrinks and swells over time, something like 7,000 square miles. These are coming in from the Mississippi River. So I don't know if this shows it very well, right? But the Mississippi River flows through Louisiana. I can't really see the deltas. I suspect this is where it's actually entering, and it's carried by currents and a combination of other forces to other places on the coast, right? Comes through the Mississippi River and through runoff and those other forces, right? We get excess nutrients from the fertilizer into the ocean. We have a bloom. We suck up all the oxygen and everything dies, right? It comes from fertilizer, right? But it can also come from sewage, like human waste that is improperly being put into the river. It can also come from manufacturing waste, which we also don't want. This has an impact, though. So there is a lot of seafood, right? So fish and shrimp and other stuff that is fish in the Gulf of Mexico. And now, right, how much fish are we going to have here? Not very much, right? So I've included this just to kind of give an example, right? So on the one hand, we say, okay, yes, well, farmers need to make food. Food is good. We want them to do that. We want them to be able to produce. But we have a negative externality, right? We have a side effect, right? Which is harming food production in this other area. And if something like this were addressed, right, everybody's going to have more food. We're going to have a system that doesn't burden people who are in future generations either, right? It can be sustained. Fertilizer runoff is one very poignant example of the way that soil can be contaminated and the way that fertilizer practices and soil practices can harm the environment. But it can also just be directly contaminated. And this is broad. We could spend an entire unit on this if we wanted. 3 sources of this generally, right? So we have industrial waste, right? So this is a site in, I believe, London, England, right? We have some sort of manufacturing facility, probably from a previous era when people just dumped stuff into the ground and said, oh well, and a lot of communities are still dealing with that to this day. I would suspect that this is still their equivalent of like a brownfield, some sort of site that you cannot use, right? Careless agricultural practices can do this: excess pesticides, fertilizer, or improper waste disposal. Now, we say waste here, right? Maybe we're thinking about, cow poop or like the animal world, but this can also include municipal solid waste, aka trash, or like electronics, batteries, things that people throw away and don't necessarily think about once it's gone, right? And this is going to lead directly into our most common contaminants, right? So oils, especially hydrocarbons, right? But other forms of oil that are not necessarily processed easily and which tend to sink, which is really bad. Pesticides, right? Chemical pesticides applied in mass tend to seep into the soil and actually into groundwater and can sometimes spread into an entire what's called a plume, which is really bad. Solvents, including industrial solvents. So solvents, what does this mean? It's a chemical that we're applying to be able to strip something, right? Essentially, we're playing chemical Legos, right? And a solvent is going to take a chemical off of something. It's a simple way of putting it, right? Extremely common done that we would have industrial solvents in a sort of previous era, pre-1970, but especially maybe 1960s, where a lot of stuff that was excess industrial solvent was just dumped straight into the ground. There is an example of this in the Phoenix area. I believe it is the old Motorola plant at 52nd Street and McDowell. I'll put it in a note, but anyway. Folks using industrial solvents who would just pour them straight into the ground, and it's still there. Lead and heavy metals, right, directly related to improper waste disposal of especially electronics and other more advanced manufactured stuff, advanced tech. This is one example, right? So waste from developed countries is many times shipped to developing countries to be buried in a landfill, or sometimes, as we'll learn more about, right, it is branded as recycling in that developed nation, but it ends up getting put in a landfill anyway, or it gets sold in bulk for a very low price to these developing countries, right? Where people, right, human beings, as their job, source of income and livelihood, will go and pick through the trash and the waste of developed nations, looking for electronics, looking for parts, looking for things that they can sell or supplies. Environmentally, this is about the worst environment that a person could grow up in, especially a child, and a lot of the heavy metals especially tend to seep down into the soil and ends up causing lots of problems. It's not good. Okay. That is going to close our section on soil. What are the big questions we should have in mind finishing out this section, right? So where do organisms get their energy and nutrients, right? We talked about animals and all life as being constantly exchanging matter and energy with its environment. What matter? What energy? Now we know, right? We can organize things into trophic levels or into food chains and food webs. And we can also look at the flow of nutrients through carbon and nitrogen cycles, which, importantly, both of which involved not just the living organisms themselves, but the whole ecosystem, right? The living and non-living parts together that it flows through. What sorts of relationships exist between these species, right? They are feeding on each other, but there's other relationships as well, right? So this term symbiosis, as a broad term that encompasses mutualism, commensalism, and parasitism, it would be good to know what each of these mean and to know an example of each. We know what soil is, where it comes from, what it's made out of, why it's important, what it holds in it. And maybe we don't have all the horizons memorized, but we do understand the general trends and we understand the general process of how soil is formed. Finally, we talked about how soil can be contaminated, about the reasons behind that, about the consequences, and importantly, about how we have to frame this in terms of context, in terms of urbanization, differences between developing and developed countries, in order to get to useful, productive solutions to the problem. Solutions whereby everybody winds up with more of everything because we have solved some of these conflicting incentives, right? Fertilizer overuse, runoff, which leads to blooms and dead zones, and then landfills and e-waste, which can contaminate soil. And with that, I think we have it. Thank you so much.